Thanks for joining. With a lot of people joining on. So what I'll do is just start a preamble to what we're talking about. So the design of a packaged sewage treatment plant is quite a complex topic and one we're often asked to talk about. It's, how you go about a design and how you select the correct treatment plant with the different configurations. One of the main things we're experiencing now is the demand for increasing water quality of sewage treatment plants, um, whether it's going into, usually when it's going into a water course, a marine environment, or again, a lot of people are looking at reusing, especially in countries or areas where there's a challenge as regards potable water availability. So it is quite a complex topic. What we're trying to do today is give an overview of the whole process from start to finish, so you'll have a good understanding of how to approach selecting a packaged sewage treatment plant. One thing I'd underline is selecting packaged sewage treatment plant is both a mixture of technical knowledge and experience. And we have got quite proficient at it because we have nearly 40 years of in the market in 50 different countries in every possible region in the world. So what we're trying to do is give you an understanding of how we go about it, but we're always here to help. And we also, what we do is provide complimentary design, help and advice to our customers right from the start and through the design life. One of the questions I got in beforehand is asking how old is our oldest packaged sewage treatment plant? Well, we have one that's 38 years old that we know that's still operating, and one we regularly maintain is in the Cage Fields, which is on the west coast of Ireland, which is quite fitting. It's the oldest Neolithic field system in the world that they found, and it's one of the oldest packaged sewage treatment plants probably going in the world, and one of the most exposed places in the world. So I'll move on. And as I said, this is interactive. So please ask any questions you have at any time orally. You'll have to unmute yourself or via the text feature. Now, so the structure of this presentation or webinar is a brief introduction to what I've done. I'll tell you a bit about myself and the company. And then what we'll start off is where to start sewage treatment design. Sewage treatment, like any subject, has evolved quite complex terminology. So we'll go through the main terminology. It's not possible to cover every bit of terminology, but if you have a specific question that I don't cover, please ask. Then I'll do a work design calculation. This work design calculation is a more complicated one, and we include nutrient reduction as well as BOD and suspended solids such as ammonia, total nitrogen, and phosphorus, and different situations such as housing and retail and commercial all discharging into the unit. So it makes the calculation quite complex, but it shows you how to do a more complicated one. Then we'll talk about how a sewage treatment plant works in brief, what it does and how it treats sewage. And then we'll look at our system, the BMS Blivet packaged sewage treatment system, which is uh, all over the world in 50 plus countries for well over 35 years. Look at two or three case studies, and then we'll show you some different sites and conclude with some questions and answers. So about me, my name is Tommy Butler. I'm a specialist in packaged sewage treatment, pump stations, and vehicle water recycling solutions. I've been doing this since 2008, but the company, which was founded by my father, has been doing it since 1986. We have 40 years experience worldwide in 50 plus countries, and that can't, one thing that's said to us is we underplayed that knowledge and experience. The one thing about our industry is it's quite a conservative industry, and it takes a long time to prove a product and then a long time to establish a product. But when you have a proven product that works and does what it says, it's really important. And having the experience behind that is really, really important for most discerning clients and engineers, because there's a lot of people come into the market and try and make quick sales at all costs, and the consequences, are way down the road. We design sewage treatment plants to last 30 plus years. So that's that's the lifespan or the outlook you should be looking when you're designing selecting a sewage treatment plant, not next year or the year after, and what it'll cost to run and supply. And as I said, we provide a full complementary design service with customized designs for each of our project for all our customers. And we are there from start to finish. We have files for every treatment plant we've ever produced, and we even got one there question from Scotland, which is 35 years old, and we're providing spare parts and we're making them at the moment. So, package sewage treatment or sewage treatment design. Where do you start? Well, there's four main areas, but first of all, what is the source of the sewage? Because that dictates a lot of the design. Is it from housing? Is it from tourism like a hotel? Is it from an office, a school, a work camp? Because the type of person or that is providing sewage into the system and what the concentration of the sewage and the flow of the sewage varies for each situation. The most stable, most easy calculation to make is for housing because generally the organic pollution they produce in terms of BOD and suspended solids and is quite stable. But when you go into especially retail schools and things like that, you can get very high concentrations relative to flow. And you probably see at the bottom there, I said sizing is always a max biological load. A mistake, or we see again and again, is people coming to us with flows without reference to what concentration it is, and that will often lead to a plant being woefully undersized, especially when it's outside a housing situation. So when you know the source of sewage, if it's an existing plant, there may well be a flow meter or something like that, and samples with concentrations. So that's just a matter of multiplying that out. But in a lot of situations, they're new build, so you have to work with tables of typical numbers. So, for example, is there 100 houses with four residents in each house and 50 creche users, and maybe there's a shop on site with 10 other people in it. So you need to work out the maximum number of users. Then it gets complicated. Well, it used to be a lot simpler, but it's quite complicated now. What discharge standard is required? It varies from country to country and locally, but it's often dictated by where the treated sewage is going. Is it going to a percolation area or soak away? Is it going into a watercourse or marine environment? Is it for reuse? Or, for temporary situations, sometimes it goes into a sewage treatment plant that's overloaded, but you need to treat it to a certain standard. Typically, if it's going to percolation or if it's going to soak away, the standard is less stringent than when it goes to a marine environment. Because in that situations, the actual amount of ammonia, total nitrogen, phosphorus is very critical to stop eutrophication, which is algal blooms and stopping fish kills and things like that. And also what the level of pollution already in a river or marine course is. And other factors, is the sewage treatment plant temporary or permanent? Is it is grease traps are really, really important in any kind of commercial situation, from any takeaways, restaurants, hotels, anywhere there's commercial cooking taking place. I can't overemphasize this. If properly maintained and sized grease traps not installed, no sewage treatment technology will work properly because fat stops oxygenation of bacteria, and you get blockages everywhere, all the piping blocked, and it stops proper sewage treatment. Another factor, is it a phased development? Are a certain amount of houses or commercial going to be built and then others added on later? So you can plan a sewage treatment plant to be added in steps to spread the cost. And another really important thing is domestic versus industrial sewage. Domestic sewage, by and large, is within a certain range of concentrations. Industrial sewage obviously comes from factories and things like that, and it varies. It varies a lot. Abattoirs versus a meat factory versus a paint factory, anything like that. And what they need is one-off designs. So when we're talking about packaged sewage treatment, it's generally referring to domestic type sewage. So, as I said, find what is the source of sewage, work out maximum numbers, then work out the discharge standard required. I'll go more into that later on. And then you have to look at other factors, and sizing is always based on the max biological load, not the flow. So this where it gets really exciting, the terminology around sewage treatment. Now, many of you might know all about this already, but I'm going to go through it fairly quickly. But if anyone has any specific questions, please free to stop me at any time on the questions. Just want to check the chat. Nope, all good. Now, the first thing to do is when you hear sewage treatment, you'll hear a lot of people talking about population equivalents. And basically, a population equivalent is one full-time resident in a house or apartment. And why it's important, it's used as a way to size packaged sewage treatment plants. So you'd often hear of a 50p, P is short for population equivalent, 200p, 400p sewage treatment plant. And basically, what happens is outside housing apartment is straightforward. If you've got 400 residents, it's 400p. But when you add in retail, school, hotel, nursing home, and things like that, and offices, what you generally do is calculate the max load and then bring it down to population equivalents so you can compare treatment plants effectively. So it's generally 60 grams of BOD in suspended solids and 200 litres of flow per population equivalent a day. Just to emphasize, the 60 grams of BOD in suspended solids is generally quite consistent. The flow can vary a lot from country to country, anything from 80 litres where there's a huge water conservation up to 250 to 300 litres where there's a lot of water used, and that varies from country to country. And simply what the BOD is, it's the pollution potential of sewage, and it's generally, as I said, about 300 milligrams per litre at the inlet. It's measured over 5 days by a test, so it takes quite a while to get the results back, and it's only what is biologically treatable or oxidizable, and that ties in with chemical oxygen demand, which is simply the same as BOD, but it also takes in pollutants that are not biologically oxidizable, and it's generally 2 to 3 times that of the BOD. It's a fairly set ratio. Now, the good thing about COD is that COD is normally it's a very quick test. So once establish a ratio of BOD to COD, you can get a good idea of a treatment plant inlet and outlet very quickly. And it's normally 600 to 900 milligrams per liter. And if the COD is way up in comparison to BOD, if industrial pollutants, and you have a problem, they shouldn't be getting into domestic sewage. Suspended solids are what they say. They're the fine solids you see in a sample that don't settle, that settle over time, and they're measured by a simple enough test. So COD and suspended solids can be got quite quickly. Generally around 300 milligrams per liter at the inlet and 60 grams of population equivalent. If there's garbage grinders or anything like that, that can shoot up. But um, every situation, as I said, is unique and every design is unique. So we do it on that basis. And how do you remove BOD and suspended solids? Well, by settlement, where you remove most of the suspended solids, and primary and final settlement, and biological treatment. And if you want to get the BOD and suspendeds down a lot, you might need tertiary polishing to get below 10 milligrams per litre. So, any questions after that? And moving on. So, we talked about flow.
No, hi, I have a question.
No problem, Robert.
Hey, Tommy, how are you?
Great, thank you.
Something Tommy helped me with a Hayat in Guyana. How do you deal with blended BODs? For example, we would normally apply 1,200 for kitchen, 150 for laundry, and 280 for domestic waste. And how would that factor into your PE, or is that something you will address further on?
Yeah, well, generally for a hotel, it's not normally separated out per different parts of the hotel. Generally with luxury catering, you do get bigger flows, and that's for definite, maybe 250 and 300 liters, and the BOD rises up to 75 grams per population equivalent generally. So we would generally design for a bigger load coming into the plant. And if there's samples or concentrations locally, based on flows and concentrations, that's what we would also use if a very accurate calculation is required.
You see, we also have local authorities having jurisdiction. And our local is the Water and Sewage Authority. And they mandate certain BOD levels depending on the use of the space, for a kitchen for
Yeah, yeah,
laundry, domestic, etc. So
yeah,
we have to subscribe and we have to provide calculation to them when we have to justify the size of the plant for, well, both hydraulic and biological load. Huh?
sure. Yeah, as I said, flow is a complex thing, and that's what I'm going into there. Generally, you look at the dry weather flow, which is the flow over 7 days with no rainfall, but and that's what your true sewage flow would be. But then, if there's any surface water infiltration, which you often see in is allowed for in the Caribbean, you have to add that in on top of it. Generally, the figures from our experience over the 40 years do not vary too much, but the only accurate way to honestly the figures we use are a guide and they're pretty good, but the only definite way to do it is a flow meter and inlet samples. And you combine those together and you get your total load and concentration. Sometimes it ends up being established after, but if there's water use restrictions, the concentration can shoot up majorly. There's a hotel we dealt with in Ireland where they woefully undersized the treatment plant load because they had a license based on flow rather than concentration, so they put a lot of water saving restrictions in, but the organic load was absolutely off the Richter scale compared to the flow.
Thank you.
Yeah, thanks, Robert. Um, yeah, and as I said, flow it, as the dry weather flow is the true flow without any surface water added in. In an ideal world, there'd be no surface water getting in with the sewage, and in newer developments, this is often possible. But if this is not possible, it needs to be notified and taken into account because although it won't lead to the organic flow going up, it can lead to massive flow peaks, and it could lead to a plant being flooded if it's not planned in properly. The flow pattern again, as we're talking about housing versus tourism. Generally, in housing now, if you have an area that's very heavy commuting with people going very early and late, you can get quite high peaks. But generally in housing, the flow is relatively steady over maybe 16 to 12 to 18 hours per day. You don't get very big peaks. Obviously, you get more in the morning, evening. But with hotel and tourism, especially, a lot of people get up in the morning, they shower, they go down for breakfast at the same time, and same in the evening. So you can get very, very high peaks. So if you're getting very high peaks, you need to plan in design to minimize that. And we'll talk about later, but a balance tank or a bypass is a very good way to manage that. And ideally, any sewage treatment technology, what they like is, to put it crudely, is they like smaller regular meals rather than one or two uh, big meals per day. And that, the flow affects the settlement and affects biological treatment and the contact time with a lot of technologies. Now we have a plug flow technology that is, biological treatment full, gets full treatment no matter what the flow up to a certain limit, of course. But the settlement is affected by the flow coming in, so that's important to bear in mind. So moving on, this is where it gets somewhat tricky. Treating, BOD and suspended solids is relatively straightforward. Primary settlement, biological treatment, and final settlement. And once you know the load, it's normally quite easy to achieve. The international standard would be around BOD 25, suspended solids 35, or BOD 30, suspended solids 30. But when you're going, especially discharging to a water course or something like that, you're looking at reducing often total nitrogen now. But to start with, you often mandated to reduce ammonia because ammonia is the most readily usable by plant matter in water to produce algae blooms and things like that. Obviously, ammonia is added. It's the main thing added to fertilizer, or the main. So it causes explosive protein growth. So if it's going to a water course, generally you'll have an ammonia standard, and a typical one maybe 5 milligrams per liter. Um, Ammonia plus nitrate plus some organic nitrogen equals the total nitrogen standard. Um, Generally, it's about 8 grams per population equivalent. This can shoot about 40 milligrams per liter. This can shoot the concentration can shoot up when there's low flows. In France, you typically see maybe 80 to 100 milligrams per liter. And ammonia, once it's planted in, is pretty straightforward to remove, but it takes about 3 to 4 times the oxidative capacity to remove 1 gram of ammonia relative to 1 gram of BOD. So this needs to be borne in mind. So when you're doing a calculation for it, you'd work out the actual ammonia removal. And in a hot country or consistently warm climate like the Caribbean or Australia, you'd use a multiplication of 3. And in temperate climate like Ireland or in many of the European countries, you use a multiplication of 4. So straight away, when you're adding in ammonia, it can bring up the size of treatment plant quite a bit. And if you have a total nitrogen standard, which is we're seeing more and more, 50 milligrams per liter would be quite typical. The actual process where you remove ammonia actually just converts it to another form of nitrogen called nitrate. And to remove nitrate, it's a lot more tricky, but very possible. It's a process called biological anoxic denitrification, where if sewage, fresh sewage, and clean sewage that's high in nitrate, where you've converted ammonia to nitrate mixed together in an anoxic environment. Now, anoxic is not no oxygen, it's just without adding oxygen, and mixing takes place. They will actually, a certain type of bacteria will use nitrogen instead of oxygen for respiration, and will convert the actual nitrate to nitrogen oxygen gas with some mixing will go off into the environment, and that's part of the nitrogen cycle. And the nitrogen oxygen then are fixed back in the soil by nitrogen fixing bacteria. And then the last one is phosphorus. Main source is washing, laundry, and cleaning and things like that. And to remove phosphorus, it's generally by chemical precipitation, and there's no really easy way around it. There is a biological process, but it's very, very tricky and it's not really feasible in practice. So, what final effluent standard we looked at? We said calculate the load, and then what we need to discharge standard. Well, generally you start off at something like BOD 25, suspended solids 35, which is the European Wastewater Directive. In and around that in the Caribbean, it can be more like 30 or 35 milligrams per liter. And then how much you're reducing it to, well, it really depends on licensing authorities and the pollution, everything like that. But we have plenty of sites with BOD and suspended solids below 5, ammonia of 1 to 40, total nitrogen of 10 to 40 milligrams, and phosphorus as low as 1 or even 0.5. And just to underline, the more intensity you have to treat, the more the treatment plan goes up, and it's not necessarily in a straight line. It can jump up, and the more operator experience and monitoring is required. And as I said, where it's going largely dictates that if it's going to percolation or soak away, if it's going to the soil, it generally is, you'd see something more like BOD 25, 35. If it's going to a water course, generally you'd see a good level of ammonia removal required with or without total nitrogen removal and phosphorus. If it's for reuse, sorry, there's a typo there. This is an interesting topic. If it's going to reuse, and especially for irrigation, we've had many conversations with many authorities about this. If you're going to reuse it, what you really want to concentrate on is bringing the BOD and suspended solids down as much as possible with proper disinfection, whether by ozone or UV disinfection. Because if you're putting it back into the soil, um, the ammonia and the nitrogen and the phosphorus are what makes plants grow. So spending a lot of time and money on reducing these and then put water back in the soil only to add fertilizer does not make a lot of sense. We have a golf course in the south of Ireland, and believe it or not, it doesn't get as much rainfall in the south of Ireland as the rest of Ireland. And David Lagoon, where we're treating it to well below 10 BOD 10, spent solids 10. I'll show you it later on, and with full disinfection, and that's going to be used to water the golf course because it actually gets quite dry there during the summer. There's also local factors, and sometimes you'd be going to a sewer if it's a temporary sewage treatment plant or an overloaded plant. So just a quick before I move on to the worked example. Um, so you work out what your influent load is, then you size an organic load, avoid flow bias. Obviously, you need to know the flows coming in, and especially if there's surface water infiltration. There's a very useful table by the EPA in Ireland, which is more or less universally applicable as a starting point, where it uses different scenarios like office, schools, bar, restaurants, and allows you just to see what one user would produce in a day, which allows you to calculate up very quickly and what final effluent is required. So is it going to percolation, direct discharge, what the flow pattern is, how long is it is it temporary or permanent development? Is it phase development you want to put in one plant an hour later? What are the civil works footprint required? Is there going to be effluent reuse? Is there going to be financing? What's the portability? Will it be can it be relocated and can it be above or below ground? Lots of other factors to consider, but as I said, we're just touching on everything now, and we're actually covered quite a bit in that time, but it's going to be tough to cover everything we have now. So a worked example. Feel free to stop me anytime. I'm going to go through this pretty quickly. The presentation will be available after if you want to look at it again. So we said, where is it coming from? So it's a mixed use development. So in this development, there's housing, there's a cafe restaurant, and there's some retail units. So you can see there's 51 bed apartments and 52 bed apartments. So what we do is generally with one bed apartment, you have maximum residence of two, and two bed apartments, three can be changed locally, but that's what we're going to look for. And you can see underneath the population equivalent is, as we said, BOD spent solids of 60, ammonia and nitrogen of 8, phosphorus of 2.8, and flow of 200 litres. So you just multiply that out by 250 residents and you get your population equivalents. Where it gets slightly more tricky is in a cafe or restaurant. So you've got two different factors to consider. You've got maximum 300 meals per day and 10 staff, and they produce different levels of flow and pollution, as you can see there. So meals, you'll be looking at 15 grams suspended solids in BOD, staff at 60 grams, and the other nutrients. And the flow, as you can see, is really low there compared to a normal population equivalent. So they're producing the same level of sewage, organic BOD concentration, but only flow of 30 litres. And that's why I say design only on flow can lead to very large undersizing of plants. And then the retail staff would be the same loading as staff from the cafe or restaurant. And finally, what is the outlet standard? Well, this one is quite a tricky one. It's BODs 10, suspended solids 10, ammonia 5, total nitrogen 15, and phosphorus of 2. So this is taking in everything you possibly can. So I'll quickly go through all the steps. So that's just taking all the different, it's taking all the different requirements, BODs, suspended parameters, BODs, suspended solids, ammonia, and phosphorus. And what we're doing is we're just taking the max number of users for each category, and we're multiplying out the different categories to get the total number. So we came up with the total flow of 55,208 litres per 24 hours, 21,000 litres, 21,000 grams of BOD. Normally suspended solids is close to that. So in this situation, it's same. 2,700 grams of ammonia and 916 grams of phosphorus. So this will go through the calculation of how we get to a treatment plant size. So first of all, as I said, let's look at the flow. So we have 55,280 litres per 24 hours, and you divide that by 24 hours to get your hourly flow, and then you divide that by 3,600 to get your flow litres per second, which is very important for determining flow peaks in litres per second. So in this development, because we're going for a maximum peak of 3 times dry weather, 3 times dry weather flow, and we already talked about dry weather flow. We're not using any surface water. We're not expecting any surface water infiltration in this situation. So 1.92 litres per second will be the flow peak we're designing for. And we did a quick calculation of 200 litres, which is roughly population equivalent in terms of flow, which will give you 276 population equivalents. And that's only for reference, just to show that when you calculate out the BOD, so one BOD population equivalent of 60 grams, and divide that into the total BOD load, you get 351 population equivalents. So if you just went on the flow, you'd be undersizing the plant quite a bit. And as I said, suspended solids are quite the same, or very similar. So this, as I said, this is where it gets tricky. I'm just trying to give an understanding. It's not possible to go into, very large detail, but if you have the understanding, you can then look at a design by someone else and say, look, I know what's going on here, and I'm happy with what's going on, but we're here to support this and everything like that. We've done it a long time. So you're getting your total ammonia load and dividing it by the flow. So we see there's 49 milligrams per liter coming in as a concentration. That's a bit higher than normal. You can get a lot higher than that. So if we subtract 5 milligrams per liter, which is allowed in the final effluent, you get 44 milligrams per liter, and divide and multiply that by the total flow, you get a total load to be removed of 2,432 grams. Now, we already talked about, you need a multiplier because the ammonia bacteria are both temperature sensitive and a lot more fragile than the BOD suspended solids, the removed BOD in suspended solids. So in a warm climate, you multiply by 3, and a temperate climate, you multiply by 4. So this is for a temperate climate. So the load is multiplied by 4, and that brings it up to 9,728 grams. And we're dividing, the population equivalents are all in terms of BOD. So we're dividing by 60 grams. So basically what this tells us is on top of the BOD, we need an extra 162 population equivalents of oxidative capacity to treat ammonia from 49 milligrams per liter to 5 milligrams per liter. And as we talked about, an oxic denitrification is needed to convert the nitrate, which is from the ammonia removal, to nitrogen oxygen gas and to get it out in the atmosphere to reduce total nitrogen. Treating ammonia does not produce total nitrogen. So generally what you're looking for is that the flow-wise, that the sewage will spend about 8 hours in balance, like or anoxic tank. And if it does that, the nitrate-rich sewage from the end, which is recycled at a rate of about 50%, and that's why we're multiplying the flow by 1.5 and dividing by 3 for 8 hours retention. So we need roughly a 30,000 litre anoxic tank for this load and flow to bring the total nitrogen below 15. And for phosphorus, as we talked about, we need some chemical dosing with either aluminium sulfate, ferric sulfate, or aluminium chloride. Depends on the preference, but generally aluminium ferric sulfate are the ones used. But big problem being, and they're dosed generally into the primary settlement tank. They are both biocidal and bulk sludge, so you really need to allow 20-25% extra capacity overall to allow for the actual biocidal effects of the ferric sulfate and the sludge bulking. So the overall load is calculated by adding the BOD load 351, the ammonia load 162, and multiplying by 125 to take percent, taking into account dosing of ferric sulfate to remove phosphorus. So overall, the total load for in this situation, which, as I said, is the most complex you're likely to get, is 641 population equivalents. So how will we achieve this? So we already talked about 30,000 litre balance tank or an oxic tank. And then we would have two plants in series to give and there are BL3 3500 Blivet models in series to reduce BOD, suspended solids, and ammonia. And there'll be 50% recirculation from the end of the Blivet treatment. And this is the nitrate-rich sewage back to the balance tank for denitrification. And at the very end, we would have a tertiary treatment or final effluent polishing filter to bring the BOD and suspended solid, which will come out the Blivets roughly about maybe BOD 20, suspended solids 20, below 10 milligrams per litre. And that's what a plant like that looks like. You can see a balance tank up front, two Blivets, and a final effluent filter with UV disinfection. And the picture below shows the balance tank, how bad it is, and then what the outlet looks like in a good situation and good level of treatment and maintenance. So I know I've covered a lot there, but I can stop here and take any questions for anyone, or I can move on. Okay, everyone's still with me. As I said, I'm available for questions after privately. You can email me at tommy.butler@butlermess.com or via our website. Now, we've discussed how to actually calculate the sizing. So what is a sewage treatment plant, and how does it work? Well, uh, there's lots of different technologies out there, lots of different ways to do it, but in general, every plant consists of the following components. So you've primary or final settlement tank up front, which reduces gross suspended solids and removes matter from sewage like rags and different things like that and non-soluble solids, and also would have sludge storage. And why you need sludge storage is that the sewage treatment process, regardless of technology, will produce a certain amount of sludge, which is a lot of it is settled solids and dead bacteria. And generally, we'd reckon about 5 liters per population per week is a good indicator with about 3% dry solids. Then it goes to some form of biological treatment. In our case, we use a combination of fixed film reaction and active aeration in the form of the BMS or rotor, which is a next generation RPC or a biodisc. But um, any active aeration technologies, moving bed reactors, and all that would be fall into that category. And at the end, there's generally a humus tank or final settlement, which settles out the fine solids at the end. And there's usually sludge returned from the bottom from this back to the primary settlement tank. And in our case, we produce net hydraulic lift through it. So there's a circulation by gravity which can be modified at the outlet. So how does all this work? Well, primary settlement, as I said, will reduce generally about 15-25% of BOD and 70% of suspended solids. And settlement is based on a very simple concept. It is the flow in meters cubed divided by the surface area meters squared of the settlement tank. And what that figure gives you is called the upward flow velocity. So it's how much settlement you're getting, allowing time for solids to settle. And generally, you'd be aiming for below 0.9 meters per hour. If it goes above this, you're going to get solids carry over and everything like that. So it's important to design for flow peaks, as I said, and there's big flow peaks to balance out the flow or if there's surface water involved. Biological treatment, well, it basically oxidizes or really crudely eats the biological matter, which is BOD, suspended solids, ammonia, and to some extent phosphorus. Phosphorus, as I said, is generally by treatment with something like ferric sulfate, which coalesces with the actual phosphorus ions which settle into the bottom of the tank. But generally, you should get 15 to 20% reduction through the plant as part of biological treatment. Final settlement, you're looking generally about a 90% reduction of suspended solids. The BOD should be reduced at this rate, although there's always BODs associated with suspended solids. Sludge storage, as I said, you generally allow for at least five liters per population equivalent per week. And what we define a packaged sewer treatment plant as, this takes it all in, is primary final settlement, biological treatment, 3 months sludge storage, all in one ready to go unit that is both transported by road and container. So I'm just going to quickly show a video on our BMS packaged sewer treatment plant, which just shows all this coming together. It'll only take a minute. Sometimes a good video can show a lot more than me talking. So is any questions so far? Okay. So I showed you the video of the plant. We talked about the basic concepts of sewage treatment. So how does it work in the Blivet? The primary unified settlement is via lamella plates, and as we talked about, it's the actual surface area of settlement which dictates the level of settlement. So lamella plates in, really substantially increase the actual surface area available for settlement without increasing the volume of the actual tank. So they provide three times the surface area of traditional settlement, so they're three times more compact. So this leads the Blivet to be the most compact all-in-one unit available, combined with the biological treatment offered by the BMSA rotor, which is a next generation RBC or biodisc. And the big thing about why such a popular technology and it's coming more and more in, especially with the focus on reducing energy consumptions and maintenance, is that they have very, very low maintenance, very low power and spare parts and operator input. Some very good technology, other technologies in the market, but generally the more complicated they are, the more maintenance, energy, and everything required. And with manpower becoming more and more expensive and hard to get, simpler solutions that work well in a simpler fashion are what we aim to provide. Um, so the actual, as you saw in the video, the rotor is 90% of surface area inside. So this produces a massive surface area. And one big advantage of the air rotor is it does the big downside with RBCs is you had a lot of shaft failures and things like that due to excess load and excess growth and bridging growth and poor performance with a lot of flow variations. And this is the same for activated sludge as regards flow variations, but it's a plug flow system, so it has to pass from one side of it has to pass right through a rotor before it can move on to the next stage. So you're assured of biological treatment at all stages. And that's what I just said there. You get adjustable circulation under gravity, which allows nutrient reduction within the unit. You can actually get denitrification and ammonia treatment within the unit, um, and also allows you to adjust if there's lower loads, and it doesn't need a minimum load. That is the one big. It's a huge advantage because, especially with a lot of activated sludge technologies, they need a minimum what they call mixed liquors suspended solids to actually work properly. They work quite well when you've got very kind of stable inlet concentrations and flows, but our system has far better flexibility with varying loads and flows. And it's really simple. You've only got a drive motor that runs 24 hours a day, maximum 0.75 kilowatt, and a sludge return pump which comes on a few minutes an hour. So it can easily maintained by a local fitter, maintainer, or local company, and all the parts are standard like WEG and SKF and things like that. So that's and it's a modular system which can be expanded in phases and easily added to. We had a system recently where I posted online where it was 15 years. The first unit went in and we added a second one on, then with load decreased, and the first unit's still working well. So it just shows how robust the Blivet is. UV disinfection, we can add it in our final effluent polishing filter or in the Blivet UV for reuse. And this has been really good for construction sites or sites without access to sewers. And all the units fit in 40-foot containers, which is extremely important for transport and everything like that. So that's the inside of a BMS air rotor. You can see it's a very intense spiral formation and very intense spiral, and that's where all the bacteria grows. What's going on the outside indicates what's going on the inside, but it's a very intense surface area for biological growth, and that's a 3D picture to live it. All Blivets fit in a 40-foot container, and they're really compact. They go in with very minimal surface with civil works, no other tankages required. So, we briefly talked on it. What might you add on along with the Blivet? Well, a balancing and screening tank, it's becoming something that we're using more and more. Basically, what you do is the tank is sized on base, if especially if there's flow peaks or you want to split the flow, but you want at least a 8 hour flow capacity, not 12 hours, and the tank fills up during peak times. And then the pumps on the outlet, which we normally use macerator pumps, are work on a timer or flow meter, so the sewage treatment plant is getting is getting the same flow all the time. But the tank will fill up during peak times and pump down during quiet times, like overnight. So it stops the plant being inundated and gives you much better flow. And it also doubles up, well, triples up actually in three ways. It can be used for denitrification if designed properly. If we have pioneered a full length baffle, which can be used to stop thrash and floating solids getting through the plant and makes maintenance very easy. So it can be a tanker can easily remove anything like rags, nappies, baby wipes, and things like that from that area, and it protects the pumps in the plant. And also allows for pumping is the easiest way to flow split. If you're splitting more than twice gravity, you can generally get blockages and things like that. And more and more you're getting tertiary polishing. So we have a system basically it's a filtration system based with a compound from Sangobin called Filtrolite, which is a desiccated special desiccated clay which has huge absorption. So when the final solids and BOD are applied to it, they get caught on the media and filtered through that, and the treated effluent comes out, and then it backwashes the solids and everything back to start regularly. So it gives a really, really good standard of effluent with very, very low maintenance and very low operating costs. And you can add UV disinfection at the end as well, which, where it's going for reuse and everything like that, as we talked about, getting BOD 10 or suspended solids 10 or even 5 with full disinfection is what you want to be aiming for if you're going to reuse the water. So that's quite a complex picture there. Sorry, a drawing just showing a plant with a balance tank up front. You can see over to the left was an old plant which we replaced. You can see two rows of blivets and final effluent filters and a balance tank up front and with recirculation back to the start. So after all, you have done the calculation, you understand that. What should you look for with the packaged sewage treatment plant? Well, as I said, comprehensive design and references, both from the company and the manufacturer, are key because, we've been here 40 years and there's many companies that have come and gone for quick sales and then they disappear. So you want something that's proven, has a good track record, and you can get spare parts and backup from. An all-in-one plug-and-play system is key. Often you might get presented with a biological treatment system, just the biological component, which might look very cheap and easy to put in, but when you have to put in separate primary fine settlement tanks and all the civil works and everything like that, it can complication and maintenance that can go up quite quickly. Can it be easily, delivered to your site via truck or container? Can it go above or below ground or fully below ground in the Caribbean? There's an option available for that. What is the maintenance, moving parts, and power consumption? I can't emphasize this enough. Different systems will have this, and we've seen it again and again, especially when it comes down to a decision by a developer that they will put in, what has the cheapest upfront price, but when the actual end user goes to use it, they will generally have the highest lifetime cost. And when you're looking at 20, 30 years, you really, really want to invest in a product that has, low maintenance, power, built to last, not something that just looks good at the upfront price. A modular system can be installed in phases that allows developments to be increased and the cost to be spread. You can add UV disinfection and it's easy to relocate. Well, that's more for temporary sewage treatment. So just a few examples to finish out. As I said, the easiest way to site the easiest situation to size a sewage treatment plant is generally for housing, apartments, homes, and everything like that. So one residence, one population equivalent, and if you're looking for a final effluent, a fairly average one at BOD 25, suspended solids 25, you can just see it's a simple calculation of taking the number of houses, the maximum of residents in each, adding those up and adding them at the end. And in this situation, you get 416 population equivalents, and our biggest single plant, which will fit in 40-foot container, BL 4000, will do a situation like this. So just to quickly to go on the bottom a bit more, 460 population equivalents times 200 litre. As I said, that can vary from country to country, gives you a total of just over 83,000 litres per day. And then the flow peak would be 2.9 litres per second. So that needs to be borne in mind, which is acceptable. If it goes over three times drier the flow, you really should be looking at flow balancing at any time. The biological oxygen demand is 406 population equivalents times 60 gram, which works out at just nearly 25,000 grams per day, which is 300 milligrams per liter, which is what we said was the average, and same for suspended solids. So it's a fairly easy to pick it out there, and that's an example of a plant in the ground. They're doing 416 population equivalents of treatment to that standard. Um, Here's a slightly more complicated situation in two phases. It was for a temporary plant a tourist area, and it's BOD 25 spells cells 35, and had to be an all-in-one plant that had to be easy to move, easy to commission and decommission. And start off with it was 250p, and then it was 500p. And the big advantage for our system is often that you add in one 250p unit and then add a second one alongside. Now, this was a slightly unusual situation in that what they actually did, you can see all the figures being calculated out here. You notice that the BOD in suspended solids and COD are a lot higher because it's in France and there's less water use. But so it was 250 PE or population equivalents in the first case, in the first phase, and 500 population equivalents in the second phase. And that's the 500 population equivalent plant going in. And just to highlight the flexibility of the Blivet, that is a second-hand unit that we refurbished. That's over 15 years old. So that was put in permanently. And the original plant actually was exported to Mayotte, which is one of the French overseas territories. And just to kind of round off here, um, this is a more complicated situation. This is a five-star hotel, which is discharging into a surface water reservoir, and this is one of the most strict standards you can get. BOD suspended solids 5, ammonia 2, total nitrogen 14, and orthophosphorus 2 plus disinfection. Um, this went in, and I'm not going to do the calculations here because we've already shown the situation, but just show the steps we had to take to put it in and get up to standard. So there was an old SBR there that was failing, so we put in a BL4000 Blivet to stop the hotel getting closed down and to aid the failing plant. Then we added in two more BL4000s, a final effluent filter, a denitrification and balance tank, and a UV disinfection. And that calculated out 926 population equivalents. And eventually, as I said, in this site, they found that they actually were on flow and they had so many water saving measures that the concentration was of the sewage through the roof. So we added in another BL4000 final effluent polishing filter. And again, grease traps were key. There wasn't proper grease trapping in place. It was blocking all the pipes and it was actually affecting the sewage treatment plant badly. But once they were put in place and maintained, the situation resolved itself very quickly, and that would be your feeling. So that's phase one, our 500p plant to supplement the failing plant. And then you can see the actual balance tank up front at the bottom, the two plants, three blivets and the final effluent polishing filter. And that's the full two lines there completed, and they're looking actually at doing a third line at the moment and extending the balance tank. So you've four different situations. You've permanent construction sites, temporary or disaster relief, and with a proper package design like the BMS Blivet, you can do all very easily. So just to finish out, round off with a few examples of different plants. This was in the Caribbean in San Martin. It is a flow split three ways to treat BOD 25 suspended solids 35 milligrams per liter, and there are 300 500 population equivalent plants. And they actually they survived a major hurricane over there as well, and they're above ground. This goes right from the Caribbean to as cold as you can get, Newfoundland in Canada. That's a 400p unit, which is treating a township and going into water. And in general, yes, white sewage is generally cooler than the ambient in very warm countries and warmer because of biological activity in cold countries. So if there is sewage flow, the actual sewage plant will go and won't freeze. We have sewage treatment plants down to -40 there, been operated quite a long time. This is one of our oldest plants. It's in Clonmacnoise, which is right on the Shannon, which is one of the oldest monastic sites in Ireland. Difficult because of archaeological restrictions, but this achieves a really, really good standard of effluent with huge flow variance from, 2 or 3,000 visitors a day in the summer to 50 in the winter. but it treats BOD spent cells, ammonia, total nitrogen, and phosphorus. And just to another variation is Blivet doing primary treatment followed by a wetland, which is becoming more popular as an area. Wetlands for primary BOD and suspended solids we found generally get blocked after a short time. But with treatment, the BOD and suspended solids being brought down, they're very good at removing ammonia and phosphorus. That's a temporary housing situation where units were put into phase basis. So that treated up to 3,000 population equivalents. And that is a temporary BL 1000 Blivet UV in Centre Parks in Ireland. And that unit itself actually is interesting. It's on its eighth or ninth site. So, the payback on them versus tankering away septic sewage is huge when considered over a few years. So um, we got through an awful lot there, and thanks for coming to the presentation. So, just a quick conclusion. To design a sewage treatment plant, you calculate the organic load coming in, you determine the discharge standard, then you select the correct system. The more treatment that is required, the more difficult it becomes. And I can't emphasize enough, every project is unique. And while we've seen a lot and we know a lot, we realize that every situation is unique, and we keep learning every day. Um, we have 40 years experience in 50 plus countries. So we treat every project as unique, and we're very proud of the BMS Blivet packaged sewage treatment solution as a way to treat sewage effectively. And we provide full design, complimentary to anyone we're dealing with, and we're happy to talk to anyone about any of the factors in it at any time. So feel free to email us or pick up the phone to us. We also have a sizing and selection manual, which will go through a lot of different scenarios and how to select the correct sewage treatment plant, including ammonia, nitrogen, everything like total nitrogen like that. If you email us, we can send it out to you, or we'll send it download link after. And that's everything included, just right up to 2 o'clock. Um, I'd appreciate any questions you have. I also I also have the few questions emailed in advance I can quickly run through if no one has questions.
Hello,
Hello.
Amanda here from Guyana. It's actually 9 a.m. in the morning over here.
Oh my God, you're up very early. Thank you very much for joining us.
Yes, so I just want to say that I think the Blivet system, it's an efficient system because it's modular. The removal efficiency, especially for organics, is high. It's easy to install. It requires low maintenance, and minimal energy is required for it to be operated. And in Guyana, I see it being applicable for multi-story buildings like these hotels that are going up. I see it very applicable to those, along with the recreational facilities that we are currently rehabilitating, and also small housing schemes. I think the Blivet system is very applicable to those. Um, I know there's one in the country at the Hyatt. I just want to know if it was connected to the building, and if it's operable. I'm not sure if the hotel is opened and if it has occupancy, but is the Blivet connected, and is it operable?
At the moment, I think they're still commissioning it, but uh, someone from Engage would be able to inform me a bit better, like Sharda or Jennifer Clark. But I can certainly check for you and update you on it.
Hi Amanda, Jared from Engage here. How are you?
Hi, I'm good.
Hi, yeah. So I'm the one actually doing the installation at the Hyatt. The Blivet is in place at the moment, but it isn't connected to the building as yet. We're looking at a installation date maybe around the end of August. So the entire project should wrap up by the end of the year.
Excellent. Thanks very much for
Okay,
that.
thank you.
So if you're interested, we're more than happy to accommodate and let you come and check out the system.
Yeah, is power connected to it? And like for example, we would want to see that the discs are rotating and so on. Is there power?
No, you wouldn't be able to see it in operation yet. We're kind of like halfway through the project right now, so it's in place. Um,
Oh,
when you more likely come, you'll probably see it fully assembled, but no power or any water running to it.
okay, because one of the things that we're trying to do is to really convince our management team to have a Blivet install at our multi-story head office, but we wanted them to see how it works. Like when it's operation, there is no smell, there is no noise, and these things.
Okay, no, I understand. But um, but I mean, we're trying to work with our client in Guyana to get it operational as soon as possible. So when we have it up and running, I believe we may have your contact. We could give us your contact, and we could arrange a site visit for you, and whoever else from
Mm,
GW may want to see the system.
yes, yes. All right, thank you.
No
Thanks,
problem.
man. Hi, Jared. Um, well, I'd run down for one question because I don't want to keep anyone, but we're asked what is the oldest plant we have. As I said, yeah, 39 years old would be the oldest plant we have, and the one in the Acacia Fields, which is it's a great visitor centre, and it's on the very, very rugged west coast of Ireland and survived that long, is the oldest one. It's about 37 years that we maintain actively, and it's been operating there for 37 years, treating the sewage from that. So the system does our system lasts a very, very long time if there's a bit of care and maintenance given to it. So, any other questions?
Yes. Hi, morning, Ainsley here.
Ainsley, how are you?
Not too bad. How are you doing?
Good, thank you.
Okay, great. So in terms of, we have a lot of the major means of procurement for projects locally in Trinidad and Tobago is via the design build route, where the contractor is really interested in only first cost. So in terms of a comparison with your technology relative to others, where do you stack up in terms of first cost?
We're definitely not the cheapest, but what we are is definitely within 2 to 3 years we are the best value because often first thing that needs to be taken into account is civil works and footprint. So that our civil works and footprint are the lowest you can actually get, and that's often not taken into account. Then also, if you have to build your own primary settlement and find settlement tanks, that's often not covered in the cost and everything like that. There's no line. It's a European manufactured product made in Ireland, and we're an expensive country. But what we always try to do is provide a great value product that's built to last. So if we can compete with the lowest price in the market, but if it's fairly, if we're fairly compared to a product as regards civil works, installation time, and certainly the long-term running costs, where we can compete on with anyone on that, and that's where we aim to compete.
Okay, understood.
Thank you so much. Okay, well, I thank you for everyone coming. There'll be a video of this after, and as I said, if you want to ever contact me, you can email me at tommy.butler@butlermess.com. You can log onto our website, and we'll send a link to download the sizing selection manual after, and a video of this will also be on our website. So, thanks so much, and thanks for attending, and have a great day.